Yes, no.
Yes, sir.
Yes. By the way, guys, please do confirm whether if there's some background noise also from my side. My side. Am I properly audible to everyone?
Yes, sir.
Okay. So we learned about combustion, right? We learned about combustible and non-combustible substances. We learned about various examples of combustion. Then we also learned about like rusting of iron, uh, reaction of magnesium with oxygen. We learned about that. We know that whenever magnesium reacts with oxygen, magnesium oxide is formed. Magnesium oxide is white in color. This is white in color. Do you know what is the nature of this magnesium oxide? Anyone?
What do you mean by nature? Like what?
Nature, whether it is acidic or whether it is basic in nature. That's what I mean to say.
Sir, is it basic?
It is basic in nature. Okay, now. See, you can recall like in your previous class, in class 7th standard, you must have studied about metals and non-metals. Materials, metals and non-metals. Magnesium is a metal. This metal reacts with oxygen to give magnesium oxide. And we know that oxides of metal are basic in nature. Chakrika, probably this and one more class. Two more classes are required to finish the chapter. Okay, na Chakrika? So keep that thing in mind that magnesium oxide is basic in nature. Then we learned about respiration, iron. Do you guys know how we can prevent rusting of iron? There are numerous ways to prevent iron from rusting. It is either by galvanization or either by making alloys of iron or by
Sir,
applying a layer of paint. Yes,
sir, is oil is basic?
this gold is basic in nature.
No,
Yeah.
sir. Oil,
Oh,
petroleum.
oil. You mean to say petroleum? Petroleum can't say for sure. We'll have to look at
Sir,
its
because
pH
it is slippery. The oil
because it is
slippery.
slippery.
Oil.
See, being slippery is not the main criteria. It's not the main criteria upon which you can classify a substance as basic. Although most of the basic substances are slippery, but meaning being slippery does not necessarily mean that it is going to be basic. Petrol
Slippery.
usually will have a pH value less than 7. If you were to talk about the pH value of petrol, it will be slightly less than 7, or almost you can say that it is neutral. Okay, now so close to 7, we can say close to 7. That would be the pH value of petrol, I would say, right now. Okay, further in the chapter, we learned about various things. We learned about this activity. We learned about inflammable substances and non-inflammable substances based on the ignition temperature. We learned about different types of combustion. Namely, there were 3 types of combustion: rapid, spontaneous, and explosive combustion. All right, now we had several examples of spontaneous combustions and rapid and explosive as well. Okay. Then we were learning about fuel. We learned about fuel, that a fuel would be any material that would be burned to produce heat. And we learned what are the characteristics of an ideal fuel, what are the uses of a fuel. Then we also did learn about calorific value of the fuel. It is basically you need to show how much of energy is emitted when you burn 1 kilogram of a given fuel. Okay, you guys tell me which fuel has got the highest calorific value out of all the fuel which we have, which has got the highest calorific value.
Sir, is that LPG?
No, not LPG.
Cow dung.
See, hydrogen gas has the highest calorific value and it has got so many uses. Okay, now it has got the highest calorific value. 1,50,000.
Oil, right?
Yes.
But you said Like what? Which oil has the highest?
No, no, I'm asked. Okay, maybe that was a slip of tongue, but I meant to say which fuel I'm saying. Which fuel has the highest calorific value?
Sulfur.
Okay, na? So then in that case, you have the hydrogen gas, almost 1,50,000 kilojoule per kilogram. That is the calorific value. All right. Na? Also, you see that it will be very explosive. So it is a bit difficult to store this. Also, hydrogen gas is the lightest gas. Hydrogen gas is the lightest gas, meaning that its density is very less as compared to all other gases. So thereby, upon burning, it will produce large amount of heat. All right now. Okay. Further, we did some practice question. We learned about history of matches. We learned about the working of a matchstick also. Nowadays, you know that white phosphorus is not being used in the matchstick. It has been replaced with the red phosphorus. Right now, upon ignition, some of the red phosphorus converts into white phosphorus, and that's
Sir,
yes.
is mustard gas like hydrogen gas?
So mustard gas is different. Mustard gas is different from hydrogen gas. Yes. Okay, no, mustard gas is a different thing. Basically, a mustard gas, what does it basically consist of? It basically consists of like a sulfur in it. Getting it? Mustard gas basically consists of sulfur in it. So that's a different thing. Okay, no, hope you're getting it. Also, technically saying it, mustard gas is not correct, not actually correct. Okay, no? It is basically a chemical name given for this. It is mustard gas. If you have to talk about that, it is made up of sulfur and chlorine. Sulfur and chlorine. All right. Now? Anyways, let's stick to what we were discussing. Then we were learning about ignition temperature. Also, that basically it's the minimum temperature at which a combustible substance will catch fire. That is what ignition temperature is. Then we learned about the necessary conditions for fire. Right now. So these were the mainly necessary conditions for fire. If you remove any one of them, then fire will be controlled. Then we learned about fire extinguishers also. We learned that there are different types of fire extinguishers, right? But the most common one of them is the one in which liquid carbon dioxide gas is fed. So we learned about that. So some of the carbon dioxide fire extinguishers, in them liquid hydrogen will be liquid carbon dioxide gas
The,
will be filled.
like
While
in the fire extinguisher, like the carbon dioxide is the better one. Like
okay, like which fire extinguisher is the best one you're asking?
yes,
See, actually, it will basically depend upon what type of fire you have to extinguish. Okay, now for example, let us say that the objects that are on fire, the objects that have caught fire, let's say if it is solid. So if it is solid substance that is burning, let us say it is plastic that is burning, some paper or plastic or wood is burning, thereby the type of fire extinguisher that you would be preferring to use, usually, as if you were to read the guidelines of what type of fire extinguishers should be used to extinguish what kind of substances, thereby this powder type of fire extinguisher would be preferred, or the one that will be used that will give out foam and water. Right now, or for example, if the substances that are on fire, if there are some electrical appliances, there you won't be using this fire extinguisher which will contain water in it. Getting it? So it will depend. But we see that carbon dioxide gas is like the universal type of fire extinguisher, can be used in almost all the cases. We learned about this, and we learned about the mechanism of the working of fire extinguisher. Basically, the thing is that upon a release of pressure, the liquid carbon dioxide is stored in it, comes out in the form of gases. And the carbon dioxide gas, it will form a blanket of layer above the fire. This layer, it will form a blanket of, it will form a blanket like a structure. And thereby, since it is heavier in density, it will displace the oxygen gas, thereby cuts off the supply of oxygen to the fire. In this manner, it extinguishes the fire. Then we learned about acid rain also, and we were doing some questions. We'll be doing some more questions, and then we'll be proceeding further. The ones which I will be highlighting, those ones you guys are required to answer. Okay. Now. Question number 60. All of you read this question and answer what the correct answer is. Then question
So
number 60.
or chat box.
In the chat box, all of you.
What extra topics have we learned after the discovery of about matchstick?
What we have learned.
Yes, sir.
See, we basically after Majestic, now we basically learned about after Majestic we learned about this. Now we learned about fire extinguisher. After that,
Okay.
not only fire extinguisher, but we learned about this thing also. No, we learned about ignition temperature. By the way, you already learned about that. We learned about fire. We also learned about acid rain. Okay, now.
Yes.
While later on also you will be relearning about acid rain.
Okay.
Anyways, you guys can answer in the class also. You know, no need to write in the chat box. We need to save our time. Khadija, you are answering. That is correct, by the way, Khadija. Others also answer. What is the correct answer for question number 60? Yes, Alif, Sandos, Ori, Chakrika. Yes, Sandus, your answer is correct. Aleph, reread the question. Your answer is not correct. For the first one, your answer is not correct. You shouldn't be answering in this manner. You have written first one. No, just write whether it is A, B, C, or D. Like that. Yeah, Aleph, now it is correct. For 61, so Khadija, you have answered. That is correct. Very good. Now, all of you have answered for the first one. It is B. Very good. Now answer the second one also. Yeah, that is correct, Santosh. Good.
Sir, can you zoom it?
Yeah, sure. Also, for those of you who have done 60 and 61, do question number 62
After
also.
this, can you explain again that what's the difference between explosive and spontaneous? Because
Yeah,
I'm
sure.
getting confusing.
Okay, no issues. See, basically, the thing is now, in the case of like in the case of spontaneous combustion, what happens? In the case of a spontaneous combustion, what would be happening? The combustion reaction would be occurring on its own, meaning that you are not lighting a matchstick near the fuel, or you haven't burnt anything near the fuel. So you are not providing heat to the substance externally. Getting it? The substance will suddenly burn into flames, and it will start to burn. Even without being heated, it will burn, and it will occur at the room temperature. Getting it? So, for example, there are some very highly reactive substances in nature. For example, white phosphorus. White phosphorus is so reactive in nature that it will catch fire on its own. So thereby it is said to, like, you are not heating white phosphorus right now. So it will automatically catch fire on its own right now. So why it happens? Because it starts to react with oxygen in the air on its own without the need of without the need of any external source of heat. So that is called as spontaneous combustion. Getting it, Santosh, now?
sir, about the explosive.
Yeah, about the explosive reaction, in that what will happen? Uh, a very fast combustion reaction will take place. A substance will burn quickly and will release lots of heat and lots of light, and it will produce sound also. Like you have example of firecracker. When firecracker burns, it produces heat, a good amount of light, and produces a sound also. It
Sir,
causes a loud sound. Yeah, Alif.
so gun is like that
Which,
when we fire.
yeah, like the gun, like gun. That is also explosive reaction, explosive combustion. Let me check the answers. For 61, Gauri, you have answer. That is correct. For
Sir, we
62,
have
you
to
have.
answer 62, right?
Yeah,
The 62
those of you
answer.
who are done, now answer the question number 62 also. For 62, you have answered. Okay, let me check that. Uh,
Sir, I don't know about the 62 one, so
okay, okay,
I
no
would not
worries.
say.
You can try another question then. Question number 63. Question number in question number 62, you are being asked which fuel has a calorific value of 40,000 kilojoule. In this one, for those of you who are answering biogas, your answer is correct. If it's not methane, okay, no, it isn't methane. Aleph. Question number 62, it's biogas. You
I
can
also
have
thought it was methane.
no, actually, it isn't methane. If I recall correctly, look at this. For biogas, it is between 35 to 40,000. Right now, so this is biogas actually. Methane has a much higher calorific value, 50,000 kilojoule per kilogram. Okay, now keep that table in your mind. Like you cannot draw
Okay,
in
sir.
sequence. You can draw this in a sequence and try to remember in a sequence. Not all of them can be memorized in sequence, but try to memorize it.
I
Let's,
send you the answer of 63.
let me check that. For 63, Khadija, first of all, what you have answered is okay. You have hydrogen gas. For 64, you have answered. That is correct. For those of you who are getting the answer of 63 as hydrogen gas, that is correct. Okay. For question number 64, guys, you have to do this one also. Let me check your answer first of all, Khadija. You have answering carbon monoxide. That is correct. If I have answered, that is also correct. Of all these, yeah, 86 number is also correct, Khadija. Very good. Okay, up to question number 67, you have answered, and that is correct. Gauri
You
for
said the answer of 64.
the answer of 64 is
Already said it.
uh,
You already said.
yeah, I already actually said that.
Carbon monoxide.
That is correct. Carbon monoxide, for those of you who are getting carbon monoxide, that is correct. Chakrika, you have answer for question number 63 as okay, that is correct. Okay, yes, Alif, that is correct. Enough. For question number 65, Sundus, what is the answer?
Sir,
Yes, Alif, Sundus.
what?
For question
Sir,
number
the answer.
65, that is Coke now, right now. Now in question number 66,
How could
which of the following burns without producing a flame? See, cooking gas, basically that is liquefied petroleum gas or kerosene or camphor. All of them upon burning will produce a flame. While when you burn coke, what is coke? Coke is basically after destructive distillation of coal, coke is obtained now. We learned about that. And coke is one of the purest form of carbon now, and it will be burning without a flame. Basic thing is that any fuel that does not convert into its vapor state when it is heated, then it will not give a flame. Like when you burn a candle wax, paraffin wax, candles is made up of paraffin wax. It converts into vapor of wax now. It converts into wax vapor. Then it will be giving off flame. But like this coke will not be giving flame because it does not convert into vapor state. Same thing is about this cooking gas and kerosene or camphor. Like cooking gas and kerosene, they are already in the gaseous state. So obviously they will be giving flame. Camphor also gives flame. Okay, let me check others answer also.
Sir, can you explain the 71?
Question number 71. It is not even here.
No,
Which one?
70.
70. Okay. Yeah, sure. For question number, just 1 minute. For question number 66, anyone of you have answer? Gauri is answering option number A. Which of the following has the low? Yes. Look again
Is
here.
that CNG?
No, it's not CNG actually. It is supposed to be, I believe it should be biogas. Maybe.
Kerosene, right?
See, in this one, you look here. Kerosene has got a higher calorific value as compared to biogas or other fuels. CNG also has a higher calorific value. Out of all the options given in this question, you find that biogas has the lowest calorific value. All right, now that is biogas. Question number 67. Let me see what you have answered. Gauri have answered option number C. What others are answering? Yeah, Sundar,
Sir.
you are answering CO2.
A.
Exactly, that is carbon dioxide. Apart from carbon dioxide, there are other gases also, which are called as greenhouse gases, like methane, chlorofluorocarbon. Getting it, guys? Okay, question number 68. What have you guys
Sir,
answered for this?
is the nitrogen dioxide? Nitrogen dioxide.
Yeah, that is also correct.
Yeah.
No, the question number 68 says which of the following gas does not contribute to the formation of acid rain? No,
Nitrogen dioxide.
no, nitrogen dioxide contributes now. If you guys can recall this concept, that acid rain is basically due to oxides of nitrogen and sulfur. Nitrogen dioxide, and due to sulfur dioxide. These are the main gases responsible for acid rain. Apart from them also, like if you look at the option says you have nitrogen monoxide, carbon monoxide, sulfur dioxide, and nitrogen dioxide. So sulfur dioxide and nitrogen dioxide can't be the answer because it says it does not contribute to formation of acid rain. Carbon monoxide and nitrogen monoxide. See, in this one, the carbon monoxide, if you were to talk about nitrogen monoxide, I don't think anything like nitrogen monoxide exists. Nitrogen oxide basically, I think, yeah, it exists. It's a chemical compound. Like nitrogen monoxide is basically NO. If you talk about carbon monoxide, this is not the leading cause of acid rain. So thereby option number B would be the correct answer for this. That does not contribute to formation of acid rain. That is carbon monoxide. Question number 69.
Let's see.
Anyone? You have answered as C. Khadija has also answered C, and Gauri also. Good. So that is basically natural gas friendly to be used in automobiles. Question number 70. It says which of the following does not involve a combustion reaction?
Let's see.
Okay. Option number C.
Which side one?
Exactly. Right now we learned that here in that case basically hydrogen is splits into helium basically. It's a special kind of reaction taking place in the sun. So option number C is the correct one. If you guys can recall,
Sir.
while we yeah.
In 69, natural gas is correct, right? 69.
Yeah, that is natural gas. See what we learned in the case of basically in the sun, what basically is happening. Nuclear fission and fusion takes place in the sun. Right now, in the sun, nuclear reactions are taking place. Getting it, guys? And they basically There's an anything regarding oxygen. You see, basically what basically happens, the two nucleuses of hydrogen will combine together to form helium, and there's a chain of reaction that goes on in the sun. Nothing much related to combustion. So let us continue together. Continue, and today we are going to learn about. First of all, we are going to learn about candle fire. By the help of candle fire, we will be learning about flames. First of all, look at this fire triangle. Right now, like fire triangle basically represents that for fire to burn, for fire to take place, basically you require heat, oxygen, and fuel. So for the generation of fire, we need these three things to be present simultaneously. Some sort of fuel or combustible material is required, then you require a source of heat, and you basically source of heat is required to raise the temperature up to the ignition temperature of that fuel, and enough oxygen will be required so that combustion will last. If any one of these will be removed, thereby the fire will extinguish. Let us learn about flame, that what basically flame is. Okay, now. So basically talking about flame, it's the visible, and it is said to be the basically a region where combustion or gaseous substances are burning. To say that, have a look at this flame. Flame is basically a region, it's an area where combustion or burning of gaseous substances takes place. Although this candle is a solid fuel, it's solid in nature, but here we are, while defining flame, I am saying that flame is an area where combustion or burning of gaseous substances is taking place. So if we heat, for example, while we learned about the magnesium ribbon, there we learned that if we heat one end of magnesium ribbon over a burner, you hold it above a burner, let's say. If you were to heat one end of a magnesium ribbon over a burner, we find that the magnesium ribbon burns by producing a brilliant white flame. We also have seen in the case of candle flame, or in a case of kerosene lamp, that a flame will be given out. So flame is basically the blaze of a fire. We say that it is blaze of fire, or in Hindi or Urdu it is called as Jasola. It is called as Jasola or Lapat in Hindi, right now. So flame is the visible and gaseous part of the fire. What we see as the flame is the light energy released due to the combustion of fuel. So in this case, basically what will be happening, the solid fuel converts into the gaseous state, and all those gases undergoes combustion to produce the flame, right? And only those solid and liquid fuels which vaporize on being heated, they will be burning with the flame. I am saying that only those solid and liquid fuels that vaporizes upon heating will give a flame. Is that clear?
So if we repeat
Yes,
it,
sir.
Yeah,
can you
repeating. Yeah, see, basically, in other words, we can say that only those solid and liquid fuels which form gases on being heated, they will burn with a flame. For example, you have liquefied petroleum gas, you have biogas. These are the gases which undergo combustion, and so liquefied petroleum gas and biogas will burn by producing a flame. If a fuel is already in the gaseous state, that will also give a flame upon burning, right now. So you guys know that there are certain fuels like wax, for example, camphor. These fuels are solid fuels. They are solid fuels. And
Sir,
upon burning, yeah,
what is paraffin fuel?
paraffin is the basically wax obtained from the fractional distillation of petroleum. In the petroleum refinery, paraffin is one of the petrochemical obtained from it. Okay, now so that is
Sir,
so,
so
so
it gets fire.
yeah, that will also catch fire. I mean to say that that is in the solid state. This candle basically is made up of paraffin wax. Okay, now right
sir.
now we are trying to understand that solid fuels like wax and camphor, upon heating, they will convert into the gaseous state. They will convert into gaseous state. So they basically vaporize or form gases upon heating. So they will be burning with the flame. Similarly, you have examples of like liquid fuel. Give some example of liquid fuel.
Petroleum.
Petrol, not petroleum. When you say petroleum, it means crude oil.
Sir, it is called
Okay.
it's known as LPG, right? LPG
Yes.
also.
Yeah, LPG also. LPG is although in the liquid state when it is stored in the cylinder. Upon turning on the nozzle, then it converts into the gaseous state. So let us take example of like kerosene or petrol, or you can take even example of mustard oil. These are the liquid fuels. You have liquefied petroleum gas also, but that would be uh, for the sake of keeping it simple. Let us take these examples only. So upon heating, they will also form vapors now. Upon heating, they also form vapors. Here also vapors are being formed. So here the state change from solid to the gaseous state. Here also the state is changing from liquid to the gaseous state. So wherever the state will change to vapor state, or you have like for example you have liquid fuel, like I mean to say gaseous fuel. What are some examples of gaseous fuel?
Mhm.
Yes, give some example of gaseous fuels. Natural gas. Yeah, you have CNG. Right now, in this you should be counting liquefied petroleum gas also, because we use it in the gaseous state only. So these are some of the gaseous fuels which we have. Upon like they are already in the gas state. So upon heating, they will directly give you flame. Right now, they will give you flame. They will also give you flame. But then you have a certain kind of fuels which will not be giving flame. For like the question is that, like talking about coal, I ever thought that upon burning why coal does not give flame? Basically, the thing is that coal does not produces flame upon burning, because the thing is that if you were to look
Because because it burns without any volatile substances.
exactly, while upon burning it does not releases vapors, it does not have got any volatile substances in it. Right now, so that is one of the main reason. Also, like coal is made up of what? Coal is basically made up of wood, right? And in the carbonization process, we also learned that all the moisture present in the wood gradually evaporates over the course of millions of years. So there is no water present in the coal. If the coal is dry, there isn't any moisture present in it. No water, no volatile substances present in it. So coal will burn directly without being getting vaporized. So we have examples of coal. It burns directly without being vaporized. Then similarly, you have some other examples also. Like charcoal. Charcoal will also not produce any flame. Coal and charcoal. So they will simply glow. Instead of that, they will be simply glowing with a red and orange color. So that is all about it. Further, when fuel burns now, whenever a fuel will burn, you can observe there are different types of flames you might have observed. Like if you were to look at the flame produced when liquefied petroleum gas is burned, or when you burn a piece of paper, or when you look at the fuel of a candle. Did you guys observe a difference between that? Like if you were to look at the LPG gas burning in the kitchen stove, it produces a blue flame. Yeah.
Yes, sir.
While you look at the wax
sir.
paraffin wax, basically the candle, it burns by producing a yellow flame now.
Yes, sir.
Yes, sir.
Sir, but when the LPG flame is like over, like less it will flame like it will fire like that orange yellowish color.
Yeah, sometimes if the burner is rusted, then it will produce the slightly yellow flame will also be present in it. Okay, now candle flame image you already saw.
I was asking when the LPG gas is less the flame that yellow comes yellowish color.
At that time, basically what happens now, there it would happen because you know LPG cylinders are basically made up of iron, and iron gradually gets rusted. So whenever this little amount of the fuel is there now, so basically it will be burning, but it will be reacting with the rust also. Rust present, gradually the burner gets rusted now. So it due to the presence of rust, its color changes to slight yellow or orange.
Okay, sir.
What I was saying that when fuel burns, the type of flame, basically here we are referring about the color of the flame, will depend upon following factor. The first factor is availability of oxygen. If the air supply is good, thereby it will burn completely, almost completely, and thereby will give you a blue flame. If the oxygen supply or air supply is insufficient, then the fuel burns incompletely, thereby producing mainly a yellow flame. So the first thing is that if you have sufficient air supply, we are basically referring to oxygen here. So sufficient air supply, thereby fuel burns completely. So if it burns completely, thereby it will give you a blue flame. As we can see in this case, as you can look at this image over here, a flame like this will be observed. Second case is that if insufficient air is there, insufficient air, in that case, fuel burns incompletely. Getting it, guys? Thereby that will
Yes,
give
sir.
you a yellow flame, as simple as that. Also, the yellow flame is basically caused by the glow of unburnt carbon particles produced due to incomplete combustion of fuel. What I'm saying here, I said that yellow flame, it is produced due to combustion of unburnt carbon particles. And those unburnt carbon particles, combustion of unburnt particles, and where are those unburnt particles coming from? See, if you ever did this thing now, like on a burning piece of candle, if you were to place a piece of a thick paper or something at a height so that it does not catch fire, it will develop a soot. You will find that a soot will develop over it. Have you observed that? In Hindi, we call this as kalai, or a black spot appears over it. What is that black spot? These black spots are basically the unburnt carbon particles. right now. We know that this fuel will consist of carbon. When this will be vaporizing, so thereby carbon will also be found in its gaseous state, or also this thread that is burning. So when this fuel is burned, due to some reasons, it will not be burning completely. The gases will not be burning completely. So there will be some carbon particles which will be unburned. It will not be burned properly right now. So that's why it gives a yellow color. If it burns properly, then it will be a blue color. Hope you guys are getting it.
Yes, sir.
So yellow flame basically produces light also now. Like if you have a blue flame, you guys tell me, like if you want to illuminate a dark, so you would be turning off the gas stove or you'd be lighting a candlestick.
Candle.
Lighting a candlestick.
Candlestick, obviously, because the yellow flame is much luminous. It is said to be luminous flame or light giving flame as compared to the blue flame. So one more thing we can observe here, that this is light giving flame. Light giving flame, or that basically it is luminous flame. Hope you guys are getting it. So whenever wax, basically when wax burns in the candle, it burns with a yellow luminous flame, and the color of that flame is mainly yellow. While in the case of kerosene also, you'd observe that many times kerosene, when it is burnt in a lamp, earlier kerosene lamps were very popular in India, in certain parts of India. Today also in villages it is used. So there also it would be giving a yellow luminous flame. Okay, now. So that is one such example. So for yellow flame, you have two examples. You have candle. Second one, you can take example of kerosene burnt in kerosene lamps. You know why kerosene, when burnt in the kerosene lamp, gives a yellow flame, but if you were to burn it in open, thereby it will not give a yellow flame. Majorly, it will be giving you a blue flame. If you were to look at the structure of the kerosene lamp, it is closed. It is enclosed by a glass like this. Getting it, guys? Kind of like this, no? Kerosene lamp. So there, due to insufficient air, we are seeing that this fuel will give a yellow flame. Otherwise, if you were to burn it in sufficient air, it will give a blue flame. Hope you guys are getting it. Okay, now. So these were the two cases. The first, sufficient air supply, another insufficient air. But these will determine. When oxygen supply is sufficient, fuel burns completely, producing mainly a blue flame. And the blue flame does not produces much light, so it is said to be a non-luminous flame. What do we call this as? Non-luminous flame. So that is the thing about it. Okay, now. And here the fuel gets almost completely burned. Next, we are going to be learning about the structure of a flame. A flame will consist of three zones or three parts. These are as follows. These are the innermost zone. There would be middle zone in it also. Have a look at this image first. There would be the outermost zone of the candle flame. Then you have the middle zone and you have the innermost zone. Okay, innermost zone. Further, if you were to talk about the innermost zone of a candle flame, look at this. This is the innermost zone of a candle flame, and the color is black. Right now, so this is the dark zone of the candle flame, and it will consist of hot, unburnt vapors of this candle. Innermost flame of a candle consists of hot, unburnt wax vapors. So here the vapors are not burnt. Thereby, it gives the darkest color, that is black. Also, furthermore, if you were to talk about the innermost zone of a candle, this is least heat. This is least hot. Okay, now? This is the least hot part of the flame. Keep that in mind. So we learned three things about it. First thing, obviously, like it is the innermost zone. Another thing is that it is black in color, and this is the it contains unburnt wax vapors. So hope it is clear. So if someone asks you what is the coldest part of the candle flame, that is the innermost. So since nothing is burning here, that's why it is unburnt. That's why it is cold. Further, you have the middle zone, and middle zone is the basically it's yellow in color. The middle zone of a flame is yellow in color. It is bright, as you can look in the image, and it is luminous, meaning that it gives off light. And the fuel vapor burns partially in the middle zone. What is happening here? The fuel vapor burns partially, or also we say that incomplete combustion occurs here. The fuel vapors, like in this case, you have the wax vapor. Now, if there were to be another fuel, you would be calling it like that. So fuel vapor burns partially in the middle zone, also called as the luminous zone. Hope so far it is clear. Okay, now you know that this partial or incomplete combustion of the fuel in the middle zone, it will produce carbon particles. It will produce carbon particles, and these carbon particles becomes very hot. These carbon particles will become hot, will become white in color, and will emit out light. So the reason why this is luminous, it gives off light, because there are unburnt carbon particles in the middle zone, and these unburnt carbon particles becomes very, very hot and gives off white and yellow light. So it is due to the glow of hot carbon particles in this, which makes the middle zone of a flame luminous in nature. And these carbon particles then will leave the flame as smoke and soot. Now the carbon particles that became very hot and they were giving off light, now they will start to rise, right? And they will leave off this flame in the form of soot, and in the form of smoke also. You can observe it like also when a candle extinguishes, now like when you blow off a candle, you would observe a smoke. What is that smoke basically? Those were the carbon particles in it basically. Is that clear to everyone so far?
Yes, sir.
Sundus, you getting it? Khadija, Alif,
Yes, sir.
Chakrika, Gauri?
Sir, what's the first one? So,
What's the
above smoke.
above smoke? That is soot, S-double-O-T. Okay, now.
Okay, sir.
Also, look at the size of this zone. This occupies the maximum size in the candle flame. Now. So this is the major part of a candle flame. Is it clear so far?
Yes, sir.
Okay. Let us now learn about the outermost zone of a flame. That is also called as non-luminous zone. Here you can notice one thing, that it is blue in color. Remember what we learned about blue flame, that it is non-luminous now? Does not produces much light. So in the outer zone of a flame, the complete combustion of the fuel will be taking place. Now you can relate it from the example of LPG. Right now, why it was giving off the blue color? Because it will be burning in sufficient supply of air. Also, you can understand it in this manner. Like this is the innermost zone. It is not getting sufficient amount of air now. That's why there are unburnt carbon particles in it, unburnt wax vapors in it, I mean to say. Getting it, guys? In the second zone, this is having much access to oxygen as compared to the innermost zone. Thereby, partial combustion was taking place here. As you go to the outermost zone, complete combustion will be taking place here. Okay, now, so in the outer zone of a flame, complete combustion of the fuel takes place because there is plenty of air around it. And this has, you guys tell me, will it not have the highest temperature in the flame?
Sir, can you repeat?
Shouldn't this have the highest temperature? Shouldn't this outermost flame have the highest temperature?
Yes, sir.
Yes.
Right now, it should be having the highest temperature because complete combustion is taking place. So this is the hottest zone of the candle flame. This is the blue in color and complete combustion occurs in this. Also, the outermost zone of a flame is quite thin as compared to the middle zone. You can clearly see the thickness is very less as compared to the middle zone. Hope you guys have understood this. Now, here's why an activity also you guys can understand this. This activity would be basically based to show that innermost zone of a candle flame consists of unburnt wax vapors. Also, furthermore, by placing a cardboard over this, or basically you can take a clean glass plate, you can hold it above the candle, and here you can prove that the middle zone of a flame consists of unburnt carbon particles. Okay, now, so there are three things you can do. First activity you can do to show that the outermost zone of the candle flame is the hottest. That is the first thing you can do. Second activity we are going to learn about is that the middle zone of the candle flame contains unburned carbon particles in it. That you can do by placing a glass plate above it, and a blackish structure will appear in it. That is basically due to soot. Furthermore, we can understand one more thing, that you will observe that the innermost zone of a candle flame consists of unburnt wax vapors. Let us learn about these things. Do we have time left? Yeah, I think we have time left. At least two of them we can discuss today. Okay. See, in this you have this activity basically is telling you, it is basically about burning of this flame. In this, basically you have burnt a flame. You have lighted a can. I mean to say, you have lighted a candle. Now you have taken this glass tube, and notice where you are holding it. Can you guys tell me on which zone you have hold it? This glass tube, is it
Innermost.
So
innermost zone? Innermost zone, very good. Innermost zone, also we call it as the dark zone. And in the innermost zone, guys, what is released? What is found in the innermost zone of a candle?
Unburned carbon. Carbon.
Unburned carbon particles isn't found in this one actually. In this one, if you can recall, and it told you that unburned wax vapors are found in it. Unburned
Okay,
wax vapors. Unburned carbon particles will be found in the middle zone. Keep that thing in mind. Okay. So as you burn this candle, so thereby the unburned wax vapors, you are holding this glass tube near to the middle zone, and I mean to say in the innermost zone. So unburned wax vapor will pass via this glass tube. All right, and as you bring this matchstick near to it, thereby you can observe in this that it will burn with a dazzling light. Right now, so here actually the supply of air was difficult, since this was the innermost zone of the candle flame. So wax vapors, as it passes through this glass tube, and as you bring a lighted matchstick near this, it will burn with a dazzling flame. Getting it, guys?
Yes, sir.
What does that prove? What does that prove? What do we conclude from this? In this, what can we conclude? We can basically conclude in this that the innermost zone of a candle flame consists of unburned wax vapors. Now,
Yes, sir.
innermost zone of a candle flame consists of unburned wax vapors. Hope you all are getting it. If anyone
Yes,
has
sir.
any confusion in it, please do let me know. There are two more activities. We'll be learning about them in the next class. The next class, the chapter will be finished. Basically, we are going to learn about the environmental problems caused due to burning of fuel. We'll be learning about 2 activities and doing some question in the next class. Okay, na?
Okay, sir.
Chakrika, you have a test tomorrow?
Yes, sir, of math.
Okay. Okay, guys, so that's okay.
Exam.
Thank
Oh,
you,
okay.
sir.
Oh, wait.
Bye, sir.
Hold on for a minute. We still have got some time. Answer these 2 questions first.
He oral or in the chat?
In the class only.
Sir, it's B.
B.
It's be good.
C. Carbon
Carbon
monoxide.
monoxide. Carbon monoxide. Very good. All right. If anyone has any other questions in the class related to the activity which we have done today, remember, do ask me. And what you are required to do, you would be drawing a structure of the candle flame. Draw a structure of candle flame, okay, na? And send it to the counselor. Send it to the ma'am, okay, na? You have to draw this structure and write in a point-wise manner different characteristics of each zone. Is that clear?
Yes, sir.
Yes, sir.
Okay, then that's it for today.
Mhm.
Bye, sir.
Bye.
Yes, sir. Yes, sir.